Okay, well, missing values of lines comes from section 3.7 in your textbook. We're going to write equations for linear functions that may or may not supply this initial value and the constant change. Yeah. And then we're going to describe the slope and the intercepts. We're just going to do what we always do, make it count. So I have a couple of recalls for you. Constant change. So remember the constant change or the pattern, the plus 2, plus 2, plus 2, or whatever. That is what the change, it's a ratio of the change in the response to the change in the explanatory variable, or dependent and independent. And that ratio is most commonly written in textbooks and taught as this formula, y2 minus y1 compared to x2 minus x1, which we recognize to be the slope. So again, recall that the constant increase, the pattern, is the slope. And then also remember that the line equation is the response variable, or the dependent variable, is equal to the initial amount and then increasing or decreasing at some constant change, however many times the explanatory variable says. And so it either added that constant change however many times, or it subtracted that constant change however many of times. And if we want to rewrite this in textbook form, that would look like, so the response variable, or the dependent variable, is y. The initial is b, the y-intercept, and plus the constant change is the slope, and the explanatory variable, or the independent variable, is usually called x. Okay, in example 1, it talks about alcohol. Now I need to say this even though I don't call it a disclaimer, but it's worth talking about. A lot of students have a clearly visual and sometimes visceral response to the subject of alcohol being talked about. And a lot of people giggle and a lot of people wince. So I want to make sure everyone, is a little bit sensitive to this topic, because the reason why people giggle and wince is because they're uncomfortable. And I think that the reason people get uncomfortable talking about alcohol is that, when people overdo it, sometimes people have loved ones who overdo it, and this could cause some serious problems within a family or within a friend circle or whatever, within society. So I just want to make sure everyone knows, and they should be caring about each other when it comes to something like this, okay? The effects of drinking are described in the table. And this, by the way, this example comes straight from your textbook, the Mercer and Sebecki text. BAC stands for the blood alcohol concentration. It is a percent. The legal limit for driving is a blood alcohol concentration of 0.08, which means that 0.08% of a person's blood is actually alcohol. The average adult has about 1 gallon of blood in their entire system. 0.08% of that gallon of all of your blood in your body is approximately 3 droplets. But when we think about droplets, think about a gallon of water and putting 3 droplets of a dye in it. It's going to discolor and it's going to diffuse within the whole gallon of water. And that's similar to the effect of alcohol. So, what blood alcohol concentration do people mean when they say a person is 3 times the legal limit? Jeez, 3 times the legal limit. Here we go. 3 times 0.08. Or if you want to look at it this way, 0.08 added 3 times. Yeah? 3 times the legal limit is 0.24. Okay, what effect would this have on a person, or what effects would this person be experiencing? Well, 0.24, that's between a 0.20 and a 0.30. If 0.24% of your blood is alcohol, then you're in a tough spot here. You know, you can't function well, you're getting sick, you might even be having some convulsions or some seizures or tremors. People call this blacking out. You can't remember what's happening, and your body is actually starting to cool, which is not quite good for your body. So what effects are you experiencing? You are not in a good space. Sick. You have poisoned your body. Okay, so a person started drinking at 9 p.m. and continues to have 2 drinks per hour until 1:30 a.m. This person, that's not a situation that is without, like reason or comes up often. This person's blood alcohol concentration would peak at about 0.16 at 2 a.m. So I first want you to notice that they stopped drinking at 1:30 a.m. and it still is metabolizing and peaks at 2 a.m. Data shows that a typical person metabolizes alcohol at a rate that makes the BAC decrease by 0.015 per hour after the person's blood alcohol concentration has peaked. Write a linear equation that represents this situation. Okay, so just so that we're crystal clear, the blood alcohol concentration is going up as you drink. It goes up for a little while after you drink, and then it starts coming down. Yeah? As you stop drinking and your body metabolizes it. Filters it. Okay, so let's go like this. I feel like in order to write a linear equation, we need an initial value. Okay, the initial value, it peaks. It peaks at 0.16 at 2 a.m. That's the initial blood alcohol concentrate before it starts coming down. But we also need the constant change. Constant change. Because remember, I'm thinking about this, right? If we're writing a linear equation, we need the initial and we need the constant change. Okay, so the constant change, here it is. It's decreasing by 0.015 blood alcohol concentration per hour. Got it. So decreasing or going down 0.015 per hour. Okay, so here's what I have. The blood alcohol concentration, or the response variable, is equal to the initial and then minus 0.015 however many times. Well, per hour, so for however many hours. Yeah? So every hour that passes, you take away another one of these. That's your pattern. Got it. How long would it take this person to be able to drive legally? Okay, I have to go back because I don't memorize these things. 0.08 is the legal limit. Okay, so that is a blood alcohol concentration of 0.08. Okay, so I look up to this equation and I think, am I putting something in for hours or am I putting in something for the blood alcohol concentration? And it gave us the blood alcohol concentration. So 0.08 is equal to 0.16 minus 0.015, however many H's go by. Okay, well, when I look at this, I recognize that 0.08 is actually twice as much as 0.16. So 0.16 take away 0.08 will make 0.08. And now if you do something like this, you will come to the same conclusion. But I recognize that I have this, and if I take away 0.08, then I will actually equal 0.08. So that means what? 0.015h has to equal 0.08, because then this equation would be true. And either you can start putting in hours and seeing what multiplies to get this, or you can undo this operation and divide or scale down both sides by 0.015. That's what I'm going to do, of course. Call me lazy. What is that called? Thinking smarter rather than harder. Let's see. So h is equal to 5.33333333333. I'm going to turn that into a fraction. So math frac this. Math frac. And when I say math frac, I really do mean on your graphing calculator. And that is 5 1/3 hours. Okay, but that's awkward. A third of an hour. Where an hour is 60 minutes. And so if I take that 60 minutes and I put it into 3 equal portions, 20 minutes each. 5 hours, 20 minutes. Okay, so we've answered half of this question. How long would it take this person to be able to drive legally? 5 hours, 20 minutes. What time would that be in this scenario? Well, these hours are actually hours after the peak, hours after 2 a.m. So actually, we better write this up here. So BAC, blood alcohol concentration, and hours is, or H is hours after 2 a.m. Okay. It's really important to clarify. So what time would this be? Well, they stopped drinking at 2 a.m. So what is that? 7:20 a.m. is when this person would be able to drive again. So I want to make a comment really quick, because a lot of people who drink, they stop drinking and they're like, you know what, I'm going to hang out for an hour and I'm going to have some coffee and water, and then I'll be sober enough to drive. But the reality is, if you did this behavior, you wouldn't actually be sober or legally able to drive, sober enough, right? You wouldn't have enough gone out of your body until 7:20 a.m. So a lot of people convince themselves that they can drive way earlier than they realize or they should. Okay, find the output if you input 1. Okay, now so see, these terms are so awkward. So let's bear down on them. So, what do you mean here? Input. So usually that is the explanatory variable, and in this case that's the hours. Okay, and output. Response or the dependent variable. Okay, so if we look back up at our equation, here we go. We are inputting 1 for this H, and we're finding the blood alcohol concentration. Okay, so BAC is equal to 0.16 minus 0.015 times 1. And let me put that into my calculator. And okay, 0.145. Got it. Then write a sentence describing what that means in the context of the situation. Well, if H is 1, it's 3 a.m. So after 1 hour, so again, this whole driving situation, so at 3 a.m., this person's blood alcohol concentration is still at 0.145. Okay, which, back to that chart that came from your textbook, 0.145, still, you're still having troubles here, okay? Like this, your poor judgment is slowed thinking. Your slowed thinking is making you make decisions that are not that great. So even after an hour, yep, not ready to drive. Graph this line and label everything. Okay, well, the first thing I'm going to need in order to graph is I'm going to need a table of values. Okay. Since this is going down so slowly, I mean, look at that, 0.145. I'm not going to plot 0.145. I'm actually going to count by twos. So okay. And then I'm going to find these blood alcohol concentrations. Well, if no hours have gone by, then it starts at the initial blood alcohol concentration of 0.16. If 2 hours go by, 2 of these 0.015s have been taken away, and I believe that that's what, 0.03. So 0.03 taken away would be 0.13. Okay, and now I can keep doing this pattern, yes? So 0.13 less than that would be 1/10. 300ths less than that would be 0.07. 300ths less than that would be 0.04. 300ths less than that, 0.01. Got it. Let's create this. Okay. On my vertical axis is the responding variable, so that is blood alcohol concentration. And along my horizontal axis is the independent variable, or the explanatory variable, hours since 2 a.m. And now we need to make a scale. I need it to go up to at least 0.16. And I think these go by 5s. So I think what we'll do is maybe make this 0.10. 0.20. That way I have enough. And I think this is going to count by twos. 2, 4, 6, 8, 10. 12, 14, 16, 18, 20. Yeah, that'll do. Okay, so these are all counting by 0.02s. And my horizontal axis, up to 10. Oh, okay, that's fine. Then I can actually use 5 and 10, right? 5, 10, 15. I'll count by ones down there. But always starts at 0. 0 at the left and 0 at the bottom. With constant, right, like equal increments starting at 0. All right, let's plot this. So 0.16 at the initial time. There we go. And 2 hours later, we're at 0.13. So this would be 0.10, 0.12, and 0.13 there. And 2 hours after that, at 4 hours, we're here. At 6 hours later, 0.07. So 2, 4, 6, 7. And 8 hours later, we're at 0.04% BAC, and then at 10. Okay, got it. Here's my handy ruler. Okay, looks something like, oopsie, something like that. Okay, so here's my linear equation, and it's true that I didn't label these coordinate pairs, but this is what I meant. A reader should be able to look at this and know exactly what every coordinate pair represents. So they need to know this is blood alcohol concentration and that this is hours since 2 a.m. Yeah? Okay, so this is good enough for number 6. what is the x-intercept of this line? Okay, well, we actually haven't ever talked about this up until this point, but I'm sure your teachers of the past have. And x is the explanatory variable or the independent variable. So that's along the horizontal axis. And it looks like it's happening right there somewhere. So just under 11, perhaps. Just under 11. Well, the truth is we can find exactly where that happens because we know the blood alcohol concentration. At that point, the blood alcohol concentration is 0, right? So I'm going to go back to my equation. I'm going to put in 0 for the blood alcohol concentration, and I'm going to figure out how many hours that was after 2 a.m. So let's do that really quick. If 0 equals 0.16 minus 0.015 times h, or however many times based on the hours, that means that 0.015h has to equal 0.16 because when you subtract them, you get 0. Scale this down, so scale down both sides by 0.015. So 0.16 divided by 0.015, and we get 10.6 repeating, which then I'm going to rewrite as fraction. 10 2/3 is where this happens. Okay, what does that mean? 10 2/3 hours later. What's a third of an hour again? An hour is 60 minutes. Chop it into 3 portions. 60 minutes split into 3 equal pieces. That's 20 each, and this is 2 of them. So this is 10 hours, 40 minutes. Okay, got it. So what is the x-intercept of this line? 10 2/3, or 10 hours, 40 minutes. What does it mean in the context of this scenario? Okay, this person, so instead of saying just under 11 hours later, I'm actually going to go ahead and find the time of this. So this person is finally alcohol-free. No alcohol in their blood system. Okay, let's work this out. Started at 2 a.m. 12 hours after 2 a.m. is 2 p.m. And then, okay, so 2 hours before that would be 10 hours. So that's noon. So 12:40 at 12:40 p.m. the following day. Oh, well, I can't really say the following day because at 2 a.m. it is already that new day. So this person is finally alcohol-free at 12:40 p.m. Okay. I actually have a couple of remarks when thinking about this situation. So my first remark is this. This situation, this example, gave us the initial value of, so it gave us the y-intercept. So this example gave us or told us or supplied us, whatever you want to say, the initial value of 0.16 blood alcohol concentration. And that means the y-intercept was given. So if we look back at the equation, here it shows up in the equation. here it shows up on the table of values corresponding to 0 hours passed by, and here it shows up on the graph of the line. So there's the y-intercept. So the y-intercept was 0.16 BAC. Okay. And in addition to that, they also gave us the constant change. So we use the constant change in order to figure out the equation of the line. Okay, you know what, I'm going to go ahead and put that in here too. This example gave us the initial value. It also told us the constant change slope. Decreasing by 0.015 per hour. Okay, and then we also, at the end of that example, found the x-intercept. So when finding the x-intercept, which also had a good meaning, or had meaning. So where it crosses here, that has meaning, and where it crosses here, that has meaning. This is the initial value when things begin, and this is when it hits some barrier. That was the alcohol-free barrier in this particular situation. But when finding the x-intercept, you need to replace the response variable sometimes known as the y variable, as 0 and solve. Okay, so in this case, we plugged in 0 for the BAC and solved to find H. Okay. In the next example, we're going to look at another scenario, but we may not be given the initial value and we're not given the constant change. So we'll figure out how to deal with that.